Students, can you see now the audio and video? Students, can you see the audio and video? Is it properly visible and audible? Is my voice is audible properly? Yeah. Right. The next concept. So after this, we have oxidation. Alcohols, oxidation. See, alcohols oxidation, we are going to use PCC or PDC, pyridinium chlorochromate or pyridinium dichromate. Okay. Otherwise, we are going to use third one, copper at 300 degrees centigrade. Copper at 300 degrees centigrade. See, what will happen? The primary alcohols CH3, CH2OH. The primary alcohols CH3, CH2OH. Primary alcohols. By using any of these reagents, PCC or PDC or copper in 300 degrees centigrade. Any of these three reagents can convert into aldehydes. How do they convert? They convert into aldehydes, primary alcohols. Whereas secondary alcohols you can take. Secondary alcohols. Secondary alcohols means CH3, CHOH, CH3. This is secondary alcohols. By using these reagents, it can convert into CH3, C double bond O, CH3, ketones. Whereas, let me take tertiary alcohols. Tertiary alcohols means CH3, CH, this is C, CH3, CCH3, OH, which is a tertiary alcohol. By using 1 and 2, you could not get any reaction, but third one can bring alkene by dehydration. Alkene by dehydration, but not aldehyde or not ketone. Okay, దీనిపైన కూడా అడుగుతాడు చూసుకోండి. Okay. Strong oxidizing carboxylic acids. CrO3 if you use strong oxidizing agent which can convert carboxylic acid. Okay. Now see the question. Kala is the conversion. CH3, CH2, Cl, alcoholic KCN, A, which is going to treat it with tin HCl, tin concentrated HCl. You can get B. The B on treatment with HNO2, you can get C. The C on further treatment with CrO3, we can get D. What is D? First one. What is D? Online students. What is D? D is carboxylic acid. What is D? The first one. The chlorine can be substituted by Cn minus. Means you can get CH3, CH2, C triple bond N. Tin in presence of concentrated HCl. Tin in presence of concentrated HCl. What will we get? You can use sodium in ethyl alcohol. Okay. Sodium in ethyl alcohol, what will happen? Sodium in ethyl alcohol. The CN turns into CH3, CH2, CH2NH2, primary amine. The primary amines, as we discussed yesterday, by treatment with HNO2, they can convert into alcohols. They can convert into alcohols. So that you can get C is CH3, CH2, CH2. That NH2 place you can write OH. In NH2 you can write OH. On chromic acid, what will happen? Primary alcohols turns into carboxylic acids. That is CH2, COOH. COOH. Okay. Write down. Okay, next one. See the next concept. Array, Babu. Next one, dehydration of alcohols. Dehydration property. C. Dehydration property means we need to remove water molecule. The same thing I am taking CH3, CH2, OH, ethyl alcohol, by treatment with concentrated sulfuric acid. Concentrated sulfuric acid, but temperature has a vital role. Temperature has vital role. What is that? If we use 110 degrees centigrade, the product is CH3, CH2, OH2 plus HSO4 minus, because it is going to form salt. It is going to form salt. Whereas the same sulfuric acid, if you are going to use 140 degrees centigrade, then what will happen? It is going to bring diethyl ether. Diethyl ether is the product. The same thing let me take at 170 degrees centigrade, then it is going to form CH2 double bond CH2. It can form ethylene. Dehydration is observed. In the same way, if I am going to use Al2O3, anhydrous Al2O3, under 250 degrees centigrade you can get your diethyl ether, but Al2O3 under 350 degrees centigrade you are going to get, what is that? Ethylene. Okay. Okay, right, next C1, next one. So this is dehydration. Okay. Next they are going to ask one more property based on Lucas reagent. What is that? Lucas reagent concept. Okay. That Lucas reagent means what is Lucas reagent? What is Lucas reagent? What is Lucas reagent? Zinc chloride and concentrated HCl. For what purpose we are going to use Lucas reagent? What is the purpose of Lucas reagent? What is the purpose of Lucas reagent? We are going to distinguish primary, secondary and tertiary alcohols. Tertiary alcohols. Okay. The primary tertiary alcohols, if you are going to find the reactivity with concentrated HCl and zinc chloride, you can find the reactivity of tertiary alcohols is greater than secondary, greater than primary alcohols. So that is the reason for tertiary alcohols need not to add zinc chloride. Need not to add zinc chloride because the role of zinc chloride is it is going to act as a catalyst. How does the zinc chloride can act? The zinc chloride activity is like a catalyst. So as tertiary alcohols are enough highly reactive with hydrochloric acid, so need not to add zinc chloride. If you add HCl, it is going to give the reaction. So actually what kind of reaction you are going to find? You can find a nucleophilic substitution reaction. Means the alcohols are going to turn into the corresponding alkyl halides. As the tertiary alcohols are highly reactive, the tertiary alcohols brings sudden turbidity. What they can bring? They can bring sudden turbidity. Whereas coming for secondary alcohols, the secondary alcohols are going to bring within 5 minutes the turbidity obtained. 5 minutes the turbidity obtained. Whereas primary alcohols, their reactivity is extremely less, so you could not find turbidity. It doesn't mean of there is no reaction. There is the reaction, but the rate of reaction is very less. Okay. Next one, phenols. In phenols, what are the important reactions we have? Can anyone? Kolb's reaction, Raymond-Taman reaction, preparation of phenol from cumene. Many times a repeated question, okay. The first one is, if you are going to take cumene, what we are taking? Cumene. Cumene means isopropyl. What is this? Isopropyl benzene. What is this? Isopropyl benzene, which is going to oxidizes in presence of atmospheric oxygen. Then what will happen? It is going to bring cumene peroxide. What we are getting? Cumene peroxide. Cumene peroxide means CH3, OOH. This is called cumene peroxide. What is this? Cumene peroxide. Okay. Now this cumene peroxide, which is going to decompose. చూడండి ఎలా డీకంపోజ్ అయింది, ఇక్కడికి ఈ బాండ్ బ్రేక్ అయింది, ఈ బాండ్ బ్రేక్ అయింది అంటే ఏమవుతుంది? ఇట్ కెన్ ఫార్మ్ ఫీనోల్ అండ్ లిబరేట్స్ CH3, C double bond O, CH3. Acetone is the byproduct. Okay, next one, Raymond-Taman reaction. What is Raymond-Taman reaction? The phenol, yes, here we have two possibilities. The possibility 1, by treating with chloroform in presence of KOH, what can we get? We are going to get salicylaldehyde, means CHOOH, salicylaldehyde. Okay, by treatment with carbon tetrachloride, CCl4, in presence of KOH, you can get, what is that? Salicylic acid, COOH, OH. Salicylic acid we are going to get. Number of times we repeated. Important topics are, from organic chemistry we are discussing, from physical chemistry we discussed already. In our last video we have. Okay. In last video we have. Other Raghavendra, the same thing I am discussing. From physical chemistry and organic chemistry we are discussing important topics only. Okay. After completion of my class I am giving which parts are very, very important. From which chapter, okay. For medical exam they did the same thing, Ram Reddy. I think for MPC students there is no postpone exam, TS EAMCET there is no postpone. The schedule as usual, the exam will conduct as they mentioned before. Even hall tickets also released. Okay. whatever the difficult conditions you are going to face, so better to reach your exam center before the time. Okay, even it is hard. Ram Reddy. From our end, we are going to hope for the best. Okay. Right. See the next one. Next one is Kolb's reaction. What is that? Kolb's reaction. In Kolb's reaction, what we are doing? In Kolb's reaction, what we are doing? We are going to take phenol. Phenol is going to treated with NaOH and further treated with carbon dioxide and further treated with acidic medium hydrolysis. You are going to get salicylic acid. What can we get? Salicylic acid. OH, COOH. And see another important thing. The salicylic acid is going to treated with acetic anhydride, CH3CO twice O. Okay, it is going to bring acetyl salicylic acid. Acetyl salicylic acid means OC double bond O CH3. This is going to bring COOH, acetyl salicylic acid. This acetyl salicylic acid is called, what is this? Aspirin. This is also called aspirin. Aspirin. Okay. Okay, next one. Next one. Right. After phenols, Kolb's reaction, Raymond-Taman reaction, and what is that we have? The phenol is also going to involving in a coupling reaction. What is that? Coupling reaction. That is called Azo coupling reaction. What is the Azo coupling reaction? If you are going to take phenol, okay, phenol, okay, this phenol is going to react with benzene diazonium chloride. Benzene diazonium chloride means N triple bond N. N triple bond N. Okay, this is plus Cl minus. Benzene diazonium chloride. N triple bond N plus Cl minus. Okay, now what will happen? This pair of electrons are gained by this nitrogen atom. Becomes neutral. Nitrogen will carry positive charge. Now this nitrogen is going to act as electrophile and substituted at para position. So it is going to bring, this is para hydroxy OH, azo benzene, N double bond N, this is benzene ring. Para hydroxy azo benzene. What is the color of this salt? ఏ కలర్లో ఉంటుంది? విచ్ ఆర్ జనరల్లీ కలర్ పిగ్మెంట్స్. మనం డైస్ ప్రిపేర్ చేయడానికి దీన్ని యూజ్ చేస్తాం. సో వాట్ కైండ్ ఆఫ్ కలర్ ఇట్ హ్యాస్? ఏ కలర్ ఉంటుంది? చెప్పాను కదా అప్పుడు ఓ ఉంటే ఏ కలరు? ఆరెంజ్ డై. వాట్ ఈస్ దిస్? ఆరెంజ్ డై. ఓకే, the same thing or same reaction you can take by taking with NH2, aniline. Okay, the same benzene diazonium chloride you can take N2 plus Cl minus benzene diazonium chloride. So what kind of product you can find within this reaction? You are going to find this is NH2, this is N double bond N, N double bond N, that is para-amino azobenzene you are getting, which is actually yellow dye. What is this? Yellow dye, yellow color dye. Okay, next one, ethers. Next one, ethers. In ethers, what are the important reactions? The first one is Williamson ether synthesis. Okay, what is that? Williamson ether synthesis. This is very, very important. So what is the Williamson ether synthesis? What is the Williamson ether synthesis? ఏం చేస్తాం చెప్పండి. You are going to take alkyl halide C2H5Cl in presence of sodium alkoxide C2H5OH and reacts with Na can form C2H5ONa. So what can we get? C2H5O C2H5. ఇది జనరల్గా జరిగేదిరా. ఇక్కడ మనకేంటంటే రియాక్షన్లో in this reaction what will happen? Generally alkyl halides reacts with sodium alkoxide, they are going to bring ethers. Right. Listen. So now C2H5O C2H5 ether synthesis. Alright, listen. In case of substrate or reagent, the bulkiness is increases. In such a case, so instead of substitution reaction, elimination takes place. What will happen? Elimination takes place. You can see For example, if I am going to take CH3O, Na, let me treat with CH3, CCH3, CCH3, Cl I am taking. Cl I am taking. In such a case, what will happen? No substitution reaction. Elimination is favorable. Which elimination is favorable? E1 elimination is favorable. In such a case, what kind of reaction you can get? This is going to bring CH3, CCH3, double bond CH2. You are not getting any substitution. You can get methyl alcohol. You can get methyl alcohol. Means this is called substrate. Alkyl halide is called substrate. This is called reagent. The group which is going to attack on the substrate, it is called reagent. If you need to prepare the ether containing bulky alkyl group, the symmetrical ether which contains bulky alkyl group, in such a case, you need to take the bulky group over the substrate, now over the reagent, but not substrate. Substrate పైన bulky group తీసుకోకూడదు. Bulky group ఎప్పుడు ఎక్కడ ఉంచాలి? Reagent పైన ఉంచాలి. Then only you are going to get nucleophilic substitution reaction. Ante, if I am going to write like this, CCH3, 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 O minus Na plus is going to reacted with CH3Cl, then only you are going to observe by SN2 nucleophilic substitution and brings CCH3, CH3, CH3, O, CH3 you are getting, followed by SN2 mechanism to give ether. అరే ఇంకో విషయం చూడండి, ఇదే రియేజెంట్ని ఇఫ్ యు ఆర్ గోయింగ్ టు కార్బన్ కంటైనింగ్ అట్లీస్ట్ 2 కార్బన్ అటమ్స్, అంటే మెథైల్ క్లోరైడ్ తీసుకోకుండా ఇఫ్ ఐ ఆమ్ గోయింగ్ టు యూజ్ ఇథైల్ క్లోరైడ్ CH3CH2Cl, నౌ ఇట్ ఈజ్ ఫాలోడ్ బై E2 ఎలిమినేషన్ బట్ నాట్ SN2. ఇక్కడ ఏం ఫామ్ అయ్యేది ప్రొడక్ట్? ద ప్రొడక్ట్ ఈజ్ CH2 double bond CH2, because as basic strength increases, elimination favored. Which can be favored? Elimination favored. If the reagent nucleophilicity increases, that is favored for substitution reaction. That is favored for substitution reaction. Okay. ఎక్కడైనా బేసిసిటీ పెరిగితే ఎలిమినేషన్ ఫేవర్ అయింది, న్యూక్లియోఫిలిసిటీ పెరిగితే సబ్స్టిట్యూషన్ ఫేవర్ అయింది. ఓకేనా? అది కండిషన్. రైట్. అమ్మా nucleophilicity. If nucleophilicity increases, substitution increases or favored by substitution. If basicity increases, elimination favored. Okay, next. Next one. Ethers cleavage. Cleavage of ethers. How does the ethers can be cleaved? How does the ethers can be cleaved? See, how we are going to cleave the ethers. The ethers cleavage is generally followed by SN2. ఎప్పుడు కూడా ఏ మెకానిజం జరగాలి? SN2 మెకానిజం జరగాలి. అంటే the reactivity order is primary CH3X greater than, primary greater than, secondary greater than tertiary. Okay, always primary greater than, secondary greater than tertiary. ఇలా తీసుకోవాలి cleavage. While we have these groups, అరే చూడండి అన్న, in case of tertiary alkyl group or benzyl alkyl group or allyl means CH2 double bond, CH single bond, CH2. If these groups are present, ఈ groups ఉంటే the reaction is always followed by SN1 mechanism. SN1 mechanism జరగాలి ఎప్పుడైనా. Whereas these groups, vinyl group or phenyl group, phenyl means benzene ring, ఈ groups ఉంటే always followed by SN2 mechanism. SN2 mechanism. SN2 mechanism. Okay. Right. See the next one. Are questions ఎలా అడుగుతాడమ్మా? The products CH3O CH2CH3 by treated with HCl question mark అంటాడు. 1 mole of HCl treat చేస్తే products ఏమని అంటాడు. So what is the mechanism? It is followed by SN2. Which mechanism? SN2 mechanism. In SN2 we have CH3 is one alkyl group and the other one is CH3CH2 is another alkyl group. Antena? In SN2 which has more reactivity, as we discussed already? CH3 has more reactivity than CH3CH2. That means the Cl minus is the reagent which is easily attacking on CH3 rather than CH2CH3. దీని మీద ఈజీగా అటాక్ చేస్తుంది. అంటే ఏమైంది, ఈ పెయిర్ ఆఫ్ ఎలక్ట్రాన్స్ని తీసుకుంటుంది. సో దట్ మీన్స్ యూ ఆర్ గోయింగ్ టు బ్రేక్ హియర్, ఇక్కడ బ్రేక్ చేయాలి. అంటే ప్రొడక్ట్స్ ఏమొస్తాయినా, వన్ ఈజ్ CH3Cl అండ్ ద అదర్ ప్రొడక్ట్ ఈజ్ CH3 CH2 O minus and H plus becomes OH. ఇలా అడుగుతాడు క్వశ్చన్స్. ఓకేనా? This is first one. Second one, if you have like this pH CH2 OCH3 ఎలా ఇచ్చాడు అనుకోండి. In such a case what will happen? Let me use HI యాడ్ చేసా. ఏమొస్తుంది? ఆల్రెడీ we discussed if pH CH2 or CH double bonds CH2 double bond CH single bond CH2 either benzyl or tertiary or allyl groups are present. Then what is the reaction mechanism? SN1. SN1 means which has more reactive, this one has more reactive. Means the I minus need to attacks on CH2 and this pair of electrons can be gained by oxygen. So what is the product? You can write PH CH2I and CH3OH. Okay. Right, next one. Okay. Next one, aldehydes and ketones. Aldehydes and ketones. How many important reactions are we have? Can anyone? Aldol condensation. Idu telusuga. Regular ga adige questions. Cannizzaro reaction. Cannizzaro reaction. Inka? That is aldol, crossed aldol, aldol, both are same. Okay, internal, different types. Next. Rosen-Munz reduction. Okay, very good. Rosen-Munz reaction. Inka? Rosen-Munz reduction. Inka ma? Stephens reaction. Inka? Ettard reaction. Ettard reaction. Yes. Gattermann-Koch reaction and Gattermann aldehyde synthesis. Gattermann's Koch and aldehyde. Koch and aldehyde synthesis, both reactions A and B. Inka? Those are we discussed yesterday. Friedel-Crafts alkylation, acylation. Now, Japan, inke unnai. Sandmeyer, Gattermann we did yesterday. Fittig, Wurtzwittig also we discussed yesterday. I am asking only absolutely from aldehydes and ketones. Only aldehydes and ketones. Dibal H is similar within the Stephens reaction, Rosen-Munz reduction only. So these are the very, very important reactions. Okay. So one by one we can see that. First one, Stephens reaction. What is that? Stephens reaction. In Stephens reaction, what we can do? In Stephens reaction, what we are doing? RC triple bond N. RC triple bond N. It is going to reduce in presence of tin and concentrated HCl by further hydrolysis. Tin and concentrated HCl means one bond can be break down, added hydrogen, hydrogen. Okay. So can provide amine. Can provide amine. What it can provide? Amine. RC H double bond NH. Amines can be developed. Which on further acidic medium hydrolysis, H3O plus. This bond can break down, added O. Okay, so brings RCHO, that NH turns into NH3 because NH plus H2 brings NH3. That is Stephens reaction. Okay, the second one you can use in place of tin and concentrated HCl, You are also going to use Dibol H, diisobutyl aluminum hydride. The same property you can get. Amines, cyanide stands into amines. Amines further hydrolysis can develop aldehydes. That is another reaction. The next one are Rosen-Munz reduction. What is that? Rosen-Munz reduction or reaction. See, Rosen-Munz reaction or reduction. We are going to use acid halides, RC double bond O Cl. Rosen-Munz reduction, what we are using? Palladium and barium sulfate. This is actually Rosen-Munz reaction. What will happen? The Cl can be substituted by hydrogen. Reduction means we are removing Cl and adding hydrogen. So can develop RC double bond O H. The same reaction you can find either by using Dibol H also. Ide reaction Dibol H use chesina vastadi. Okay na? That is Rosen-Munz reduction. The third one, Etard reaction. This is important. Etard reaction. In Etard reaction, what we are doing? We are going to use toluene. Em use chestam? Toluene use chestam. Can be treated with chromyl chloride. Chromyl chloride means CrO2, Cl2. CrO2, Cl2. Appudu this is yes, CH intermediate em form aydani adugutadu. Chuskondi. What is the intermediate formed in this reaction? This is CrO, OH, Cl2 twice. CrOH, Cl2 twice. Ila form aydhi. Ante C carbon atom is going to binds with two groups of OOH Cl2. Which on further hydrolysis? Hydrolysis chesam anukondi. Then this can bring benzaldehyde. This can bring benzaldehyde. Okay. So coming for the next one, Aldol condensation. Alright, next Gatterman-Koch reaction ante emante chudandi. Gatterman-Koch reaction means benzene can be treated with CO, HCl in presence of AlCl3. Can form benzaldehyde. But it can form benzaldehyde. This is called Gatterman-Koch reaction. This is Gatterman-Koch reaction antam. The same reaction means benzene is going to treated with substituted cyanides. అంటే దీని ప్లేస్లో H తీసుకోవచ్చు లేదా R తీసుకోవచ్చు. హైడ్రోజన్ సైనైడ్ ఆర్ ఆల్కైల్ సైనైడ్ ఎనీథింగ్ ఇన్ ప్రెజెన్స్ ఆఫ్ AlCl3. If you are going to use HCN, you can get CHO వస్తుంది. Otherwise, if you take RCN, you are going to get this is RC double bond O ఇలా ఫామ్ అవుతుంది. If you use hydrogen cyanide, you can get aldehyde. If you use alkyl cyanide, you can get ketone. ఈ రియాక్షన్ ఏమంటామంటే Gatterman-Koch aldehyde synthesis. We have different Gatterman-Koch aldehyde synthesis. Okay. Okay, next one. Aldol condensation. What is aldol condensation? What is aldol condensation? What is aldol condensation? Aldehydes which contains alpha hydrogen atom. Aldehyde or ketone which contain alpha hydrogen atom can only give this reaction. Can only give this reaction. I am giving shorthand notations. Need not to do much more lengthy manner. దీనికి lengthy manner చేయకుండా సింపుల్గా ఎలా చేయాలో నేను చెప్తాను చూడండి. ఫర్ ఎగ్జాంపుల్ నార్మల్ ఆల్డాల్ కండెన్సేషన్. నార్మల్ ఆల్డాల్ కండెన్సేషన్ మీన్స్ యూ కెన్ టేక్ ఓన్లీ వన్ టైప్ ఆఫ్ ఆల్డిహైడ్ ఆర్ కీటోన్. ఒకేలాంటిది తీసుకోవాలి. ఓకేనా? ఫర్ ఎగ్జాంపుల్ ఐ ఆమ్ యూజింగ్ CH3CH డబల్ బాండ్ O. ఇలా ఇచ్చాడు రా మీకు. ఎసిటాల్డిహైడ్ which contains this is the functional group, this is the alpha carbon, contains hydrogen atom, so can give this reaction. Can give this reaction. In presence of mild base. Mild base means you can take barium hydroxide. Mild base. Mild base తీసుకుంటే చాలు. సో ఆల్డాల్ కండెన్సేషన్ మీన్స్ బై హీటింగ్. హీటింగ్ సింబల్ కూడా వేస్తాడు. అలా చేసేటప్పుడు ఏం చేయాలంటే you can write the two molecules in such a way in which you can write one molecule to exhibiting oxygen in one side. ఒక మాలిక్యూల్ ఆక్సిజన్ ఎగ్జిబిట్ చేసేటట్టు ఇలా రాయండి. అండ్ అనదర్ మాలిక్యూల్ యూ ఆర్ గోయింగ్ టు రైట్ హైడ్రోజన్ మాలిక్యూల్ ఆఫ్ ద ఆల్ఫా కార్బన్. ఆల్ఫా కార్బన్ దగ్గర ఉండే హైడ్రోజన్ని సెపరేట్గా రాయండి. అండ్ యూ కెన్ రైట్ ద రిమైనింగ్ హైడ్రోజన్ విత్ ద ఇంక్లూడింగ్ విత్ కార్బన్. కార్బన్తో ఇంక్లూడింగ్ ఇంకో హైడ్రోజన్ రాద్దాం. అండ్ రైట్ ద CHO గ్రూప్ యాజ్ యూజువల్. దానికి ఉండే CHO గ్రూప్ని డైరెక్ట్గా రాసేయండి. దెన్ వాట్ డూ వీ నీడ్ టు డూ? మనం ఏం చేయాలంటే ఈ రెండు మాలిక్యూల్స్ నుంచి H2O తీసేయాలి. వీ నీడ్ టు ఎలిమినేట్ H2O ఫ్రమ్ ద two molecules. So we are taking H2O so that you can write a final product CH3CH. There is a double bond between this carbon and this carbon, so you can write double bond CH3CHO. This is the final product in aldol condensation by taking only one type of reactant molecule. ఒకేలాంటిది తీసుకుంటే ఇలా రాయాలి. ఓకే. ఇఫ్ ఐ హ్యావ్ క్రాస్డ్ ఆల్డాల్, క్రాస్డ్ ఆల్డాల్ ప్రొడక్ట్ రాయమన్నాడు అనుకుంటున్నాను. క్రాస్డ్ ఆల్డాల్ ప్రొడక్ట్ CAP మీన్స్ క్రాస్డ్ ఆల్డాల్ ప్రొడక్ట్. క్రాస్డ్ ఆల్డాల్ ప్రొడక్ట్ రాయమంటే ఫర్ ఎగ్జాంపుల్ ఐ హ్యావ్ టూ రియాక్టెంట్ మాలిక్యూల్స్ CH3CHO one molecule which is going to react with CH3C double bond O CH3 ఇలా ఇచ్చాడు. Acetone is another molecule. In crossed aldol condensation we are going to get four different types of products in which two products are normal aldol products and two products are crossed aldol products. First normal aldol products రాస్తున్నాం. What we are writing? Normal aldol products. the combination of 2 moles of acetaldehyde. How do we write? CH3CH double bond O. This is another molecule H2CH CHO. By breaking here, you రెండింటిని break చేసేయండి. ఏమైందిరా? CH3, this is CH, double bond CH, CHO. This is one product. First normal aldol product by taking 2 molecules of same acetaldehyde. 2 molecules కూడా acetaldehyde తీసుకుంటే ఇలాంటి product form అయింది. And another combination, 2 molecules of acetone. What we are taking? 2 molecules of acetone. That is CH3, C double bond O, CH3, 1 molecule, and another molecule from alpha carbon, H2, CH, C double bond O, CH3. ఎలా రాస్తున్నాం? Again you need to remove H2O. So the product is CH3, C double bond, CH3, CH double bond, C double bond O, CH3. These two are normal aldol products. Right. Or next one. Crossed aldol products, how do we are writing? Crossed aldol products, how we are writing? Crossed aldol products ఎలా రాస్తామంటే, you can see, first time let me write CH3CH double bond O. దీన్ని ఎలా రాస్తానండ్రా? Means I am removing oxygen from acetaldehyde, and from acetone I am removing hydrogen molecule. CH, C double bond O, CH3, acetone. You can remove H2O. Can form CH3, CH, double bond CH, C double bond O, CH3. This is one first product, crossed aldol. Now let me remove oxygen from this molecule, acetone. So how I am writing? CH3, C double bond O, CH3. This is H2, CH, CHO, acetaldehyde. It can remove, we can remove H2O molecule from this, and you can write another possibility, CH3C CH3 double bond CH CHO. This is another possible crossed aldol product. So we can have 2 crossed aldol products. Okay, the last reaction from aldol condensation, that is aldehydes and ketones, that is Cannizzaro reaction. Cannizzaro reaction means what is the condition we have? Yes, the aldehyde or ketone which contains no alpha hydrogen atom but we have an exception, that is CH3, CH, CH3, CHO, isobutyraldehyde. Even it contains alpha hydrogen, it can give the reaction. It can give the reaction. The Cannizzaro reaction is called what kind of reaction? Auto-redox reaction, self-condensation, self-oxidation and redox reaction, self-oxidation and redox reaction, reduction reaction. That means HCHO is the molecule can involve in both oxidation and reduction in presence of strong base. One molecule oxidizes into HCOONA and another molecule reduces into CH3OH, methyl alcohol. One is oxidation and the other one is reduction. Reduction. Right, next one. Another important reaction, sir. HVZ reaction. What is HVZ reaction? Yes, alpha halo substitution. CH3, CH2, COOH, let me take. By treatment with red phosphorus and chlorine. What is the product you can find? Em product form aidi chepandi. CH3, CH, Cl, COOH. అదే చూడండి రా బాబు, అదే రియాక్షన్ని లెట్ మీ యూజ్ PCl3తో ట్రీట్ చేస్తామనుకోండి, దెన్ వాట్ విల్ హ్యాపెన్? న్యూక్లియోఫిలిక్ సబ్స్టిట్యూషన్ కెన్ ఫార్మ్ CH3, CH2, CO, Cl. ఇది ఫామ్ అయింది. ఈ రియాక్షన్ని HVZ అంటాం. ఇక్కడ ఏం జరుగుద్ది? ఫ్రీ రాడికల్ సబ్స్టిట్యూషన్, బట్ హియర్ న్యూక్లియోఫిలిక్ సబ్స్టిట్యూషన్. ఓకే, నెక్స్ట్ Hoffman bromide degradation. Hoffman bromide degradation. ఏం చేస్తాం? Amides RC double bond O NH2 can be treated with KOH and Br2. ఏమైంది? ఈ CO గ్రూప్ పోయింది, ఏం ఫామ్ చేస్తుంది? can turns into primary amine. Primary amine. Next one, Carbile amine test. Carbile amine test. For what we are going to use? For primary amine. Santana? Like anything you can take primary amine. PHNH2. By treatment with chloroform in presence of KOH can form PHNC. That is foul smell. Isocyanates formation. Foul smell. నెక్స్ట్ హ్యాలో ఫామ్ టెస్ట్. హ్యాలో ఫామ్ టెస్ట్ అంటే ఎవరు ఇస్తారా? ఏ గ్రూప్స్ పాజిటివ్ టెస్ట్ ఇస్తాయి? CH3 CHOH ఈ గ్రూప్ అయినా ఉండాలి, అదర్వైజ్ CH3 C డబుల్ బాండ్ O గ్రూప్ ఈ గ్రూప్ అయినా ఉండాలి, అదర్వైజ్ CCl3 C డబుల్ బాండ్ O గ్రూప్, CCl3 CHOH గ్రూప్ ఈ గ్రూప్స్ ఏం చేస్తాయి, కెన్ ఫార్మ్ yellow PPT బై ట్రీట్మెంట్ విత్ NaOH ప్లస్ X2 దీంతోనే ట్రీట్ చేయొచ్చు, అదర్వైజ్ NaOX డైరెక్ట్లీ, అదర్వైజ్ Na2CO3 ప్లస్ I2 వీటితో ట్రీట్ చేస్తే ఏమైంది, ద గ్రూప్ కెన్ బి బ్రేక్ డౌన్, ఈ గ్రూప్ బ్రేక్ అయింది, కెన్ ఫార్మ్ హ్యాలో ఫార్మ్, కెన్ ఫార్మ్ హ్యాలో ఫార్మ్, ద రిమైనింగ్ గ్రూప్ టర్న్స్ ఇంటూ C డబుల్ బాండ్ O ONA. ఫర్ ఎగ్జాంపుల్ యూ కెన్ టేక్ CH3 C డబుల్ బాండ్ OH ఈ గ్రూప్ తీసుకోండి, బై ట్రీట్మెంట్ విత్ NaOH అండ్ I2 దీంతో ట్రీట్ చేసామనుకోండి ఈ బాండ్ బ్రేక్ అయింది, ద CH3 టర్న్స్ ఇంటూ CHI3 అండ్ HCO టర్న్స్ ఇంటూ HCOO Na ఆక్సిడైజెస్. Yeah. Next, last one we have Victor-Meyer's test. Victor-Meyer's test. ఏం చేస్తారా Victor-Meyer's test లో? Test for alcohols. Primary alcohols can form blue precipitation. Secondary alcohols can form red precipitation. Tertiary alcohols no PPT. Okay na? Victor-Meyer's test. ఏం చేస్తాం చెప్పండి, ప్రైమరీ ఆల్కహాల్స్ కెన్ ఫార్మ్ రెడ్ ప్రెసిపిటేషన్, సెకండరీ ఆల్కహాల్స్ కెన్ ఫార్మ్ బ్లూ ప్రెసిపిటేషన్, ప్రైమరీ బ్లూ, సెకండరీ రెడ్. ఒకసారి చూడండి రా, ప్రైమరీ రెడ్ ఉంటుంది, మీకు చెప్పాను నోట్స్లో, ఒకసారి చెక్ చేసుకోండి. రెడ్ కలర్ అదే అంటేనా, ప్రైమరీ రెడ్, సెకండరీ బ్లూ, టెర్షరీ నో కలర్. చూడండి, ఆల్కహాల్స్ ఆర్ గోయింగ్ టు ట్రీటెడ్ విత్, ఫస్ట్ దేంతో ట్రీట్ చేయమని చెప్పా, ఇనీషియల్లీ వీఆర్ గోయింగ్ టు ట్రీటెడ్ విత్, దేంతో ట్రీట్ చేయాలి, NaNO2 ఫస్ట్ రియేజెంట్, ఫర్దర్ రియేజెంట్ ట్రీటెడ్ విత్ Ki, థర్డ్ రియేజెంట్ HNO2, ఫోర్త్ రియేజెంట్ KOH దీంతో ట్రీట్ చేయమని చెప్పా. If you add these 4 reagents, if you are going to get red color, red PPT form అయితే that indicates primary alcohol. If blue PPT forms, that indicates secondary alcohol. If no PPT అసలు precipitation ఫామ్ అవ్వలేదు అనుకోండి, no color, that is tertiary alcohols. Okay, this is the end of organic chemistry. Okay, I gave physical concepts, physical chemistry concepts and organic chemistry concepts, very shortcut, very useful little bit of concepts. And before that we discussed what are the important concepts are there in our previous videos. Okay, just you can collect them, and many of the online students are suffered from, and they are facing some troubles due to the heavy rains, and some of their houses and their colonies are drowned under the heavy rain water. But even whatever the hard conditions we are facing, students, but we need to attend for the examination, because there is no transfer of schedules or changing of schedules from the examinations. So you guys, whatever the conditions, even it is difficult, I can feel that, but you need to go and attend the exam. So before the time, examination time, all of you guys, you need to reach your examination centers, and you can give your 100% effort and make the things in a better way. Okay, wish you all the best. Once again, బెస్ట్ ఆఫ్ లక్. ఓకేనా, బైరా. Yeah, these named reactions are enough. Varshit, these reactions are enough.